Sir Isaac Newton was an English mathematician and natural philosopher who is considered the greatest scientist that has ever lived by many. He developed his 3 laws of motion in 1686 when he was 43 years old. According to Newton's first law, an object at rest will remain at rest unless acted on by an unbalanced force. An object continues in motion if it starts in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In this example, the volleyball is at rest because no force is acting upon it. And here it will maintain its velocity. In this example, the law no longer applies because the ball acts as an unbalanced force. According to Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass of the object, the greater the amount of force needed. The equation that goes along with this law is force equals mass times acceleration, F equals ma. In this example, we are going to find the force exerted on the ball. To find the force exerted on the ball, we must use the equation provided in Newton's second law. Force equals mass times acceleration. The force is unknown, and our mass of an average volleyball is 0.28 kilograms. That leads us to find the acceleration. So first off, finding the acceleration. Acceleration is the final velocity minus initial velocity over the change in time. We know our initial velocity is 0 meters per second. Our final velocity we figured out was 5 meters per second. Then finding the acceleration, 5 meters per second minus 0 meters per second over 2 seconds equals 2.5 meters per second squared. Then on to finding F. F equals mass times acceleration. Since we already have the mass and we just found the acceleration, this is now simple. 0.28 kilograms times 2.5 meters per second squared leads to a force of 0.7 newtons. According to Newton's third law, for every action, there is an equal and opposite reaction. In this example, when the ball begins to drop, force of gravity is applied by the earth on the ball. The ball follows the motion and accelerates towards the earth due to the force of gravity applied by the earth on the ball. In similar fashion, the ball also applies the same force to the earth and tries to attract the earth towards it. But the earth's mass is very large, so the acceleration produced in the ball is very small or negligible. To find the acceleration of the earth towards the ball, we can use the fact that both of these forces are equal. The mass of the earth equals 5.972 times 10 to the 24. The acceleration is what we're trying to find. The mass of the ball equals 0.28 kilograms, and the acceleration of the ball towards the earth is gravity, which is 9.8 meters per second squared. We can set these equations equal to each other to find the acceleration of the earth towards the ball. After doing all these calculations, we get that it is 4.595 times 10 to the negative 25th meters per second squared. Thanks for watching us explain real-world applications of Newton's 3 laws of motion.